What if I told you that everything you think you know about the universe is wrong? Not just slightly off, not just a few decimal points misplaced, but fundamentally, profoundly wrong. We, as a species, have a tendency to project our own logic onto the cosmos. We see a sunrise and a sunset, so we assume a day is a simple rotation. We see a ball. We assume it's solid. We experience heat. We assume things melt. We see space. We assume it's empty. This is our earthbound bias. It's a comforting illusion, a set of rules that work well enough in our tiny, protected cradle of life. But the universe does not care about our comfort. It does not obey our common sense. The reality of the cosmos is a bizarre, chaotic, and often terrifying tapestry of extremes. It's a place where the laws of physics are stretched to their breaking point, creating phenomena so strange they sound like a fever dream. Today, we are not exploring science fiction. We are pulling back the curtain on reality itself. We will journey far beyond our simple intuition to uncover 5 scientifically proven, 100% real facts about our universe that you simply will not believe are true. What you're about to hear will challenge your perception of possible and impossible. It will reframe your understanding of time, matter, and even your own existence. So brace yourself. We are about to look into the abyss, and the abyss is looking back. Let's begin our journey, not in a distant galaxy, but right next door with our celestial neighbor, Venus. From Earth, it is a jewel, the brightest object in our sky after the sun and moon, a beacon of light in the morning or evening. We call it Earth's twin because it's so similar in size, mass, and composition. But this twin is twisted. This twin is a vision of hell, and it holds a secret that unravels our most basic concept of time. In Earth, our rhythm of life is defined by 2 simple, separate cycles. A day is 24 hours, the time it takes for our planet to spin once on its axis. A year is 365 days, the time it takes to complete one orbit around the sun. A day is short, a year is long. It's logical. On Venus, that logic is inverted. A single year on Venus, the time it takes for the planet to complete one full orbit around the sun, is approximately 225 Earth days. Now, hold that number in your mind. A single day on Venus, the time it takes for the planet to spin just once on its axis, is 243 Earth days. You heard that correctly. Its day is longer than its year. Imagine, for a terrifying moment, standing on the surface of Venus. You would watch the sun rise in the west, because yes, Venus also spins backward, a phenomenon known as retrograde rotation. You would then live through an entire, single day. During that one long, agonizing day, you would experience an entire year. You would celebrate your birthday, your half-birthday, and your next birthday, all while the sun slowly, painfully crawls across the sky. The next sunrise wouldn't occur until 117 Earth days later. Why? The planet is a prisoner of its own atmosphere. The Venusian air is a crushing blanket of carbon dioxide, 90 times thicker than Earth's, with clouds of sulfuric acid. This atmosphere is so dense, it has created what scientists call a runaway greenhouse effect, trapping heat and raising the surface temperature to 867 degrees Fahrenheit, 464 Celsius, hotter than Mercury, even though it's twice as far from the sun. This thick, superheated atmosphere also creates what scientists call a thermal tide. It's a massive, planet-spanning wave of atmospheric pressure that moves with the sun. This tide is so powerful, it acts as a constant, massive brake, slowing the planet's rotation to this agonizing crawl. Venus is not a twin. It is a warning. It is a toxic, high-pressure inferno where the clocks are broken, and a single day outlasts a year.
Let us leave the inner solar system's inferno and travel outward to the realm of the giants. We arrive at the jewel of our solar system, Saturn. It is a vision of majesty, a colossal golden globe attended by a family of 146 moons and adorned with the most magnificent ring system in the known universe. It is a behemoth so vast you could fit 764 Earths inside it. It is a king. It looks heavy. It looks dense, powerful, and solid. But this king is an imposter. Saturn is a celestial fraud built on a lie. The single most unbelievable fact about Saturn is this: it has the lowest density of any planet in our solar system. In fact, its average density is significantly less than that of water. Let's put that in concrete terms. Water, the universal standard, has a density of 1 gram per cubic centimeter, 1 g per cm cubed. Our rocky Earth is dense, at about 5.51 grams per cubic centimeter. Saturn? Its average density is a mere 0.687 grams per cubic centimeter. This means that if you could construct a bathtub, a cosmic ocean, large enough to hold it, Saturn would float. This concept completely shatters our perception of what a planet truly is. We are biased by our home. We think of planets as hard, rocky balls like Earth, Mars, or Venus. But Saturn is not. It is a gas giant. This name is more literal than you know. Saturn is, for the most part, not solid. It is a vast, swirling, turbulent collection of primarily hydrogen and helium gas. It spins incredibly fast. A day on Saturn is only 10.7 hours, which causes it to bulge dramatically at its equator and flatten at its poles. Deep inside, thousands of miles beneath the cloud tops, the immense pressure likely squeezes this hydrogen into a bizarre, electrically conductive, metallic state. And at its very heart, there might be a small, rocky core, perhaps the size of Earth. But the vast majority of this planet is just gas. It's a colossal, spinning sphere of atmosphere. It is, in essence, a bubble. A giant, beautiful, majestic bubble of gas, so light that it would bob around in an ocean. The solar system's most magnificent-looking world is also its most insubstantial. Fact 3. The center of our galaxy smells like rum and tastes like raspberries. Music shifts to an upbeat, slightly quirky electronic tone. Curious and bright. We've dealt with time and density. Now let's talk about something truly sense-based. Let's talk about flavor. When you think of the smell of space, what comes to mind? Probably nothing. A cold, sterile vacuum. Astronauts, upon returning from a spacewalk and removing their helmets, report a distinct odor, a sharp metallic smell, like seared steak, hot metal, or welding fumes. This is likely the scent of atomic oxygen clinging to their suits. But that's just low Earth orbit. What about the deep universe? What about the very heart of our galaxy? We now turn our radio telescopes to the center of the Milky Way, 26,000 light-years away. Near the supermassive black hole at our galaxy's core, Sagittarius A*, there is a vast, chaotic, and incredibly dense molecular cloud. It's a star-forming region, a stellar nursery where new suns are born. Its name is Sagittarius B2. This cloud is a chemical soup. It's packed with a stunning variety of complex organic molecules, the very building blocks of life. And astronomers, by analyzing the specific radio frequencies these molecules emit, have been identifying them one by one. They found formaldehyde. They found methanol. They found ethanol, the same alcohol found in beer and wine. But one molecule in particular stands out in baffling abundance. It's an ester known as ethyl formate. For any chemists, perfumers, or bartenders watching, you know this molecule. On Earth, ethyl formate, C3H6O2, is the chemical compound responsible for a very specific and wonderful aroma. It is the dominant compound that gives raspberries their flavor. And if that weren't strange enough, it is also a key component in the smell of rum. You heard that correctly. The violent, chaotic star-birthing furnace at the center of our galaxy is floating in a colossal cloud that, if you could somehow sample it, would taste like raspberries and smell like a tropical cocktail. To be absolutely clear, this isn't air you can breathe. It's a cold, diffuse, and toxic cloud of gas and dust. But the molecules that create these familiar and complex sensations are there, synthesized in the vacuum of space by processes we are only just beginning to understand. The universe is not just rock and gas, it is a complex, intergalactic chemical factory. And apparently, it has a sweet tooth.
We've dealt with time and density. Now let's talk about something truly sense-based. Let's talk about flavor. When you think of the smell of space, what comes to mind? Probably nothing. A cold, sterile vacuum. Astronauts, upon returning from a spacewalk and removing their helmets, report a distinct odor, a sharp, metallic smell like seared steak, hot metal, or welding fumes. This is likely the scent of atomic oxygen clinging to their suits. But that's just low Earth orbit. What about the deep universe? What about the very heart of our galaxy? We now turn our radio telescopes to the center of the Milky Way, 26,000 light-years away. Near the supermassive black hole at our galaxy's core, Sagittarius A*, there is a vast, chaotic, and incredibly dense molecular cloud. It's a star-forming region, a stellar nursery where new suns are born. Its name is Sagittarius B2. This cloud is a chemical soup. It's packed with a stunning variety of complex organic molecules, the very building blocks of life. And astronomers, by analyzing the specific radio frequencies these molecules emit, have been identifying them one by one. They found formaldehyde, they found methanol, they found ethanol, the same alcohol found in beer and wine. But one molecule in particular stands out in baffling abundance. It's an ester known as ethyl formate. For any chemists, perfumers, or bartenders watching, you know this molecule. On Earth, ethyl formate, C3H6O2, is the chemical compound responsible for a very specific and wonderful aroma. It is the dominant compound that gives raspberries their flavor. And if that weren't strange enough, it is also a key component in the smell of rum. You heard that correctly. The violent,
chaotic star-birthing furnace at the center of our galaxy is floating in a colossal cloud that, if you could somehow sample it, would taste like raspberries and smell like a tropical cocktail. To be absolutely clear, this isn't air you can breathe. It's a cold, diffuse, and toxic cloud of gas and dust. But the molecules that create these familiar and complex sensations are there, synthesized in the vacuum of space by processes we are only just beginning to understand. The universe is not just rock and gas. It is a complex, intergalactic chemical factory. And apparently, it has a sweet tooth.
We've had a day longer than a year. We've had a planet that floats. We've had a galaxy that tastes like fruit. Now, we must go to a place that breaks the very laws of physics as we know them. A place where hot and cold lose all meaning. A world of pure, screaming contradiction. Welcome to Gliese 436b. It's an exoplanet, a world orbiting a distant star. It's located 33 light-years away, orbiting a dim red dwarf. It's a Neptune-sized planet, about 20 times the mass of Earth, and it orbits its star at an insanely close distance, whipping around it in just 2.6 Earth days. Because it is so close to its star, its surface is subjected to unimaginable, inescapable heat. The temperature on Gliese 436b is estimated to be over 800 degrees Fahrenheit, 430 degrees Celsius. It is a global inferno, hot enough to melt lead. Here is the fact that should be impossible. This planet is covered in ice. How? How can you have solid, frozen water on a planet that is 800 degrees? This is where our earthbound intuition fails us completely. This is not the ice you know. This is not Ice 1, the frozen water in your freezer, which is a hexagonal crystal. This is a bizarre, exotic, and high-pressure form of matter. It's known as Ice 7, or Ice 10, Ice 10. On Earth, water freezes at 32 degrees F, or 0 C, and boils at 212 F, or 100 C. But those rules only apply to our specific, comfortable atmospheric pressure. On Gliese 436b, the planet's immense mass, 20 times that of Earth, creates a gravitational pull so powerful, so absolutely crushing, that it compresses the water molecules with unimaginable force. The pressure is so high, thousands of times higher than on Earth, that it forces the water molecules to lock into a solid, cubic, crystalline structure. This pressure is so immense that it overpowers the heat. The 800-degree temperature is desperately trying to boil the water into vapor, but the gravity is crushing it back into a solid. This is burning ice. It is a planet with a surface that is simultaneously on fire and frozen solid. This discovery changed planetary science forever. It proved that hot, cold, solid, and liquid are not absolutes. They are relative to pressure. Gliese 436b is a monument to a universe that is far more complex than our simple, Earth-based intuition can ever comprehend. For our final fact, we must confront the most terrifying concept of all. Not a strange planet, not a flavorful cloud, not a physical contradiction, but something that isn't there. We are going to the Eridanus supervoid. For decades, as our telescopes have peered deeper into the cosmos, we have been mapping the large-scale structure of the universe. What we found is a beautiful, intricate pattern known as the cosmic web. It's a vast, sponge-like structure. There are long, bright filaments of superclusters, collections of thousands of galaxies stretching for hundreds of millions of light years. And in between these filaments are large, relatively empty regions known as voids. This is the standard model: galaxies, clusters, filaments, and voids. This is how we believe the universe is built. And then, in 2004, we found the hole. Scientists were studying the cosmic microwave background, the afterglow of the Big Bang, the oldest light in the universe. They found a particular area in the sky, in the direction of the constellation Eridanus, that was inexplicably cold, a cold spot. For years, they puzzled over what could cause it. Then they pointed their telescopes at that region and started counting galaxies, and they found nothing. This region of space was empty. When I say empty, your mind probably pictures the space between stars. That's not empty. It's full of dust, gas, and dark matter. When I say empty, your mind might picture the void between galaxies. That's not empty either. The Eridanus supervoid is empty. It is a colossal, bottomless pit in the fabric of the universe. Its scale is impossible to fully grasp. It is 1.8 billion light-years across.
Let that number sink in. 1.8 billion light-years. It would take light, the fastest thing in existence, nearly 2 billion years to cross it. Our entire Milky Way galaxy is only 100,000 light-years across. This void is 18,000 times bigger than our galaxy. This region is missing an estimated 10,000 galaxies. It is not just empty of matter we can see, it's empty of dark matter too. It is a super void, a vacuum on a scale that simply should not exist. Our best models of the universe, the ones that predict the Big Bang and the expansion of the cosmos, cannot fully explain this. This great nothing is a statistical impossibility. It is a hole in the cosmic web, a place where for some unknown reason, the universe simply stopped. It is a chilling, profound reminder that the universe is not only defined by what it is, but by what it is not. And in the darkness of the Eridanus supervoid, we find the most profound mystery of all.
A day that outlasts a year. A planet-sized bubble that floats. A galaxy's core that tastes of fruit. A world of burning ice. A void in reality, a billion light years wide. The universe is not a neat, tidy collection of spheres orbiting in perfect circles. It is a chaotic, violent, and mind-bendingly strange laboratory of extremes. A place where reality is far more flexible than we ever dared to believe.
Every fact we have explored today is not theory. It is not a what if. It is reality. A reality that has been measured, proven, and verified by our best science. And this is just what we've found so far. We are still infants standing on the shore of a cosmic ocean, splashing in the shallows. What other impossibilities are waiting for us in the deep? It proves that the most creative, most bizarre, and most powerful force in existence is not human imagination. It's the cosmos itself. So the next time you look up at the night sky, don't just see the familiar, comforting stars. See the impossible. See the contradictions. See the mystery. And remember, the truth is out there, and it is far stranger than you can ever believe.